It's time for the first batch of today's sessions. Warm welcome to Carlos, Cloud Solution Architect at Microsoft and a fellow conference organizer, with his talk on scaling multi-tenant platforms.
All right. Well, welcome everyone to my talk. Welcome to the Infinite Hotel. Today I'm going to be talking about scaling multi-tenant platforms through a unified API. And I first have to say that I am extremely excited to be here in Warsaw giving this talk. And I also have a special mention for someone in the audience. That is my friend Andy Kaczynski. At the beginning of my career, I was working in a consultancy company, struggling to find a customer, and I did an interview at some point for a job to work with Andy, to work with other great people. And I can say I probably wouldn't be here if it wasn't by the trust for people like Andy. So thank you very much, and a round of applause for Andy, please. Now, let me first introduce myself. I am Carlos Mestre del Pino. I'm an organizer of the Dutch Cloud Native Day. We've also had KCD in the Netherlands as well, although the last edition was a Dutch Cloud Native Day. I'm a cloud solution architect in Microsoft, where I help Azure customers with AKS, platform engineering, and then just general infra and networking. You can scan the code to follow me on my socials. That should take you to all my links, although these days I am mostly writing or posting in LinkedIn. So I said, who am I? But really I should say, who are we? So unfortunately, with me today, it's my friend Christopher Haar. He's a Crossplane contributor. He's a software engineer at Upbound, and where he works mostly around developer experience for Crossplane. We initially designed or wrote this talk as a submission for KubeCon, and we eventually presented it together in Cloud Native Rejects in London earlier this year. Have a little disclaimer, as I am using some supporting materials from this TED Ed YouTube video, which is the Infinite Hotel Paradox by Jeff Dekowski. I added it because I really like the graphics in there, and it's also the first time I ever heard about the Infinite Hotel was through this video, so I thought it was worth adding it in here. Now, the Hilbert's paradox of the Grand Hotel, or the more commonly known as the Infinite Hotel Paradox, it demonstrates how a fully occupied hotel with an infinite amount of rooms may always be able to host more guests. It was made for humans to try to wrap our minds around the vast concept of infinity, because we're very bad with large numbers. In this scenario, the hotel manager uses mathematics to solve problems and to accommodate new guests. So without going too much into detail, I'll just give you an example of this, and then we will move on to our infinite hotel. So say that you have this hotel with the infinite amount of rooms, and you get which is fully occupied, and you get one more guest, which is asking for a room. So how is the hotel manager accommodating? They're simply just asking everybody to move to the room n+1. So if you're in the room number 1, you will move to the room number 2, and so on. That will leave the room number 1 empty. Can repeat the same for infinite amount of guests. So if all of a sudden I'm receiving an infinite amount of number of people that wants to be hosted in my hotel, well, the hotel manager uses his mathematical knowledge to say, okay, everybody goes to the room 2n. So that gives space for all the uneven numbers. It goes on deeper levels of infinity, which I will not go into detail because they're very complex and because we don't have enough time. But please do check it out if you're a bit of a math nerd like me. Now, for our infinite hotel, I am going to be talking about, well, infinite capacity, which of course we know it's at the end is going to be limited by the capacity of our cloud provider or that we have on-prem. But I will be using the term infinite capacity. In our hotel, we are using the concept of hotel manager as control plane. So the control plane is the one that has enough knowledge of Kubernetes, platform engineering, in order to accommodate more guests. So we will be using platform engineering principles to scale infinitely. So what components would we need in such hotel? So we will first need an infinite amount of lobbies or buildings, which are virtual networks. Oh, by the way, I'm going to be talking also in the concept of, in the context of Azure, but all of these things you should be able to do in any other cloud provider or even on-prem. So we will need an infinite amount of lobbies or buildings. That's going to be the network. That's going to be the base of what we need in order to deploy our clusters, our platform. We're also going to need an infinite number of floors to host our rooms, and those are going to be our AKS clusters. On top of each of our floors, or within each of our floors, we will also need an infinite amount of rooms to host our guests. That's going to be, well, vCluster. It used to be Loft vCluster. They just renamed themselves just to vCluster, but vCluster, the project. We'll explain a little bit more about it later. We also need a gate guard to ensure that our guests are only allowed in their respective rooms. In this case, that's going to be Keycloak. And last but not least, we will need a concierge service, which is going to bring the guest belongings into the room, which is going to be Argo CD. So, as I said, the hotel manager needs to have this knowledge about the platform engineering, about Kubernetes, isolation boundaries. So let me first explain a little bit about what hard or soft boundaries we can define across the different layers of our platform. So starting with the compute, looking at a hard boundary, you could have dedicated node pools per tenant. So that would bring you to a situation in which there's no noisy neighbors, right? So each tenant will have access to a different pool of nodes, and there will be no way for one tenant to steal compute from the other one. This allows you to have independent node scaling, but nodes might be underutilized in scenarios with zone redundancy. So say that your tenant is only deploying a couple of workloads, but they need to have dedicated compute, and they need to have resiliency to zone failures. So in that case, you're going to have at least 3 nodes. But what if your tenant doesn't have enough workloads to fill up 3 nodes? Then that's going to result into a bit of an expensive situation, because you're going to be paying for capacity that it's not going to be used. But it is easier for chargeback. So of course, it's very easy to look at the costs of those node pools, and then obviously charge that back from each of the tenants. There's also soft boundaries in compute. So in here, when I'm talking about hard and soft, most of the times, hard is when you got a dedicated instance, when there's no possibility of breaking across boundaries. And soft boundaries, it's about controls when it comes to sharing certain resources. So in a scenario in which all tenants are using the same node pools, you can use resource quotas and limit ranges to limit the number of resources, so CPU and memory per namespace. Now, you will use limit ranges to set sane values on all the pods, on all the workloads, and resource quotas to cap the amount of resources that can go into every namespace. One of the downsides of this is that if you do misconfigure those resource quotas, you're going to have a larger blast radius and more noisy neighbors. So the compute is going to start being stolen from one tenant to another. It is also very important to tune them correctly to not waste resources if you're taking care of that part. But then on the other side, if your tenant says, okay, I'm just purchasing like 1 CPU and 2 gigs of memory, and if I don't use it, I don't, you shouldn't care about it. So there's also that scenario. Moving on to the network layer, and starting, of course, with hard boundaries, such as a separate subnets per node pool. So this hard boundary is dependent on compute isolation. So if you do have dedicated nodes for each of the tenants, you can also put those node pools on separate subnets. Of course, you must enable communication with system node pools. Your cluster is going to have certain components which are going to need which you're going to need for managing the cluster itself. So you will always need to allow that communication between the system node pools and any other tenant node pool. Across tenant node pools, because they're deployed into different subnets, you could route them through firewall or through network security groups to limit that traffic. Still on the hard boundaries, but thinking more about ingress and egress, so how to get into an application, how the application is leaving the cluster or reaching the internet. It's important to know that you do have more control and delegation with the Gateway API versus Ingress. That's because of all the different personas. That's because you as a platform team can define those gateway classes, can define those gateways, configure TLS, etc. Ingress is just a single resource, so who should be configuring this? Most of the times you do give the permissions for your tenants to create the ingresses, but that's also going to leave that they are going to have to configure the TLS configuration, etc. So with Gateway API, you do have a little bit more control for this. Also, when you're using Gateway API, you're actually managing external infrastructure, so you're managing the provisioning of those load balancers, so you then do have dedicated infrastructure for each of the tenants. Now, if you were in a situation in which you are not using dedicated node pools, you could look into having egress gateways, because many times the tenants are going to want to receive the traffic from expected IPs. So of course, if they have a node pool which is on a specific subnet, they can just use that CIDR range to whitelist it wherever they need to. Now, if you do not have that separation across different subnets, you can have egress gateways so that the traffic from specific namespaces get routed always through the same IP address. Additionally, you can also apply different WAF policies per tenant. So that's the web application firewall policy. So that is layer 7 policies, which again can be blocked by, or you can use to block traffic from IPs, which is more layer 4, but also by HTTP headers, etc. Now, on the network level, we also have the soft boundaries, which in this case, it's our network policies. So something that you can do if your tenants are living in different namespaces, you can deny traffic from all other namespaces. But it's very important to always still allow the traffic from Kube system towards any other namespace, and also from those tenant namespace to the core DNS. You need to be able to resolve DNS across your cluster. Now, network policies do depend on the CNI implementation. That's the container network interface. And some of them do actually not support network policies or may have a limited support for them. The performance, it's also going to be affected by the CNI. So if you have a lot of nodes, a lot of workloads, and a lot of network policies, obviously the CNI is going to have to process that. So CNIs that are reliant on IP tables are going to give usually lower performance than something like Cilium, which is leveraging eBPF in the background. Now, the thing with network policies is that, again, misconfiguration will break security boundaries, and then you will be allowing traffic from one tenant namespace to the other. So it's very important to test this, obviously, in all your previous environments, but also once you have deployed the policies, there has to be some kind of testing to understand whether traffic is being allowed or denied. Now, moving on to the control plane, and I'm going to be focusing on the API. Of course, you're having shared scheduler, shared etcd database, but now I'm going to focus on the API. And starting with the hard boundaries, well, having a dedicated cluster, right? Usually, on your cloud provider, you cannot deploy a second API server within the same cluster. So this would mean you're giving a different cluster to a different tenant. So it might also be the easier option for cloud providers where you don't pay for the control plane nodes. So in this case, Azure, actually. But in other cloud providers where you are paying for those 3 control plane nodes for every cluster, you might really want to share clusters to save costs. When you're creating, let's say, all these different clusters, you might end up having to support multiple Kubernetes versions, because perhaps your tenant, the consumer of that cluster, is not fast enough with catching up with the current updates, and you might end up, again, having to support all these different Kubernetes versions. Now, on a situation in which you're also giving entire clusters, you should still manage role-based access control, because you may still put certain workloads onto that cluster to manage the cluster or to add some tooling. So you usually don't want your tenant to still have like cluster-wide cluster-wide permissions. Otherwise, they're just getting a cluster. They can go on the portal, they can create it themselves, and it's not part of a platform. Still on the hard boundaries, you can have a dedicated API server with vCluster. So even though it's not something that you can do out of the box on your cloud provider, there is projects that can enable you to have dedicated API servers. So vCluster is just an installation of an API server that it goes on a specific namespace, and you can also have dedicated etcd databases. You can expose specific node pools from the host cluster onto the vCluster. So if you are creating dedicated node pools, you can still have this dedicated API, and it will only see those dedicated node pools. Additionally, you can sync host cluster services. So if I install, for example, Argo CD in the host cluster, and I still want the tenant virtual clusters to consume from them, I can sync a service from the host onto the guest cluster. Now, when you have dedicated API servers, you do have simpler RBAC configuration. So you're just giving access to that API, and you don't need to configure so much on the guest virtual cluster, but more a little bit on the underlying cluster. But the caveat to all of this is that it then becomes your responsibility to manage a component which is otherwise managed. So of course, if the API servers that you're managing, let's say, crash, your customers, your tenants are not going to be able to access the platform. This was something that you never had to take care of on a managed Kubernetes, on a cloud provider. And where's the soft boundaries that we have inside of a control plane? Well, that is just the namespace RBAC, or just Kubernetes role-based access control. So this is, of course, the Kubernetes native way of providing the isolation per namespace. Good thing is that you can bind roles, or if needed, cluster roles to OIDC groups. But it may limit the tenant's installation of some operators and CRDs. Of course, if I only have permissions within a given namespace, I cannot install a CRD cluster-wide or an operator. Last but not least, the cluster services and tooling, because at the end, your platform is not only going to be the infrastructure, it's not only Kubernetes. If your platform is highly dependent on authentication from Keycloak or on Argo CD to continuously reconciliate the workloads that you have defined in Git, then you're going to have to, let's say, also take that into consideration. It's still part of your control plane. It's still part of your platform. Now, the hard boundary would be having multiple instances. I have one tenant, one Argo CD, or one Keycloak. But this, of course, going to bring increased operational overhead. More instances to manage, more versions to deal with. Now, the number, sizing, and instant distribution must be based on performance. So you must understand the load characteristics of each of the workloads to know when is the performance going down. Because then you will be able to either implement like a horizontal, for example, horizontal pod autoscaler based on the amount of requests that you're receiving. And sorry, you must also understand replication needs and failure domains of each of your workloads supporting services. Moving on to the soft boundaries, then this is, of course, the shared services that have multi-tenant constructs. So while some applications don't have any kind of like logical separation, some of them do have something baked in. So in the case of Argo CD, you do have Argo CD projects, which are kind of limiting the targets as to where you can install your applications, where you can deploy your YAML to. There's also Keycloak, obviously. Keycloak has a Keycloak realms, which are just separate spaces for allowing and managing authentication towards endpoints like your Kubernetes cluster or that vCluster. Now, these kind of constructs are mostly useful for constraining access and permissions. But if tenant A is making a very heavy usage of Argo CD, then the performance might still start to go down, not only for them, but also for the other tenants. And that is how noisy neighbors may affect tool performance. So what should I choose? Like everything else, it does depend, but you always need to remember that hard boundaries are most of the times expensive, but simpler to implement, and I should have probably added harder to breach as well, or nearly impossible to breach. Soft boundaries, on the other hand, or the misconfiguration of soft boundaries can lead to security breaches and noisy neighbors, but you're usually going to be saving on costs. So now, how do we define our abstractions? Now, in my case, we have used, well, in this case, we have used Crossplane, of course, to define each of our abstractions. And you will see how everything that I have mentioned before will translate to a resource type in the Kubernetes API. So we're starting with the lobbies. Again, this is our virtual networks. We're just going to be setting, for example, the wing that we're in, which is West Europe, or a CIDR range. Now, many of these are going to be simplified just because it needs to fit in the screen. But obviously, when you're dealing with production environments, you're going to want to, let's say, configure or allow more attributes to be configured for each of the resources. On top of the lobbies, I said that we have our floor, and that is our AKS cluster. Now, how we make the relation, we just mentioning what lobby should this cluster be deployed into. What is our occupancy permit? So this is the Kubernetes version. Something about the sizing of that cluster too. So we have the square meters, and we have a count, which is the number of nodes, and a room class, which will end up mapping to a virtual machine SKU in your cloud provider. Within each floor, as I mentioned, we have our rooms, and again, right now we're only, let's say, exposing what floor it should be deployed into. And again, this is the virtual cluster that your tenants will connect to. We mentioned that we also need our gate guard. So that's going to be the Keycloak instance that's going to provide authentication into the guest cluster. It does Keycloak, it's running on Kubernetes. Well, you can deploy it somewhere else. But in our case, of course, we're deploying it into one of our floors, which we need to specify. And we're adding a name, which will be that ingress name or HTTP route for you to access the application. Of course, we have our concierge service, Argo CD, and very similar to the configuration of the gate guard. We're just saying on what cluster we need it deployed, so on what floor, what should be the name as well for this concierge, and what gate guard is it using. So in this case, there's an integration between Keycloak and Argo CD so that you can log in into Argo CD via Keycloak as well. Of course, our hotel wouldn't be anything without our tenants. And our tenants are going to be just a collection of resources deployed, in my case, on Azure, on Entra ID, and as well on Keycloak to make that authentication possible. And in here, we're just saying, what is the gate guard? What Keycloak instance should manage my tenant? We also have, of course, our guests. So these are going to be the different users. They're going to belong to a tenant, and you're going to have to add certain attributes as well, like the username, first name, etc. Oh, I think I actually missed in here the tenant that it should be part of. So how does all of this fit together? As I said, our hotel manager is an instance or a deployment of Crossplane. Now, Crossplane will need providers in order to create resources in certain backends. This is going to be similar to Terraform, but the difference is that these are going to be pods that are running in your cluster. For this, we're going to be creating resources in Azure. We're going to be creating resources in Kubernetes, as well Helm charts that we want to install into the clusters, and as well some resources in Keycloak. So that's the providers. That's what knows how to translate your YAML into API calls. But then you also need to configure the access, so the targets or those provider configs. Where are you deploying those resources to? In that case, we will have one provider config per gate guard, so per instance of Keycloak that we want to create something in. For Azure, we will have one provider config per subscription, and then we will have provider configs for Kubernetes and Helm per floor, and potentially as well per room, if we want to provide some things into that virtual cluster as well. Looking a little bit over that architecture, again, we have our lobby. We're deploying our floors inside of it. We're putting some supporting services, which in our case would be just an nginx ingress, cert manager, and as well configure with a cluster issue with Let's Encrypt. We have a room, or sorry, any infinite amount of them. That counts for every other resource, by the way. And we're also going to have our concierge and our gate guard. Now, in this scenario, you do see it deployed within the same floor, but you could actually have deploy the gate guard, the concierge, in a different AKS cluster and still provide the authentication mechanism for the virtual cluster within this one. So your guest will then talk to the gate or go through the gate guard onto the room, and it will go also for logging into Argo CD. Now, this is a hotel, and we want to provide certain things inside of the rooms. So we just have our, let's say, our food server, our room service. And in this case, they have ordered some of pierogi. Sorry if my pronunciation is not very good. And I really hope they like them, because they're going to get an infinite amount of them. Now, how am I doing with time? OK. Let me move on to the common platform scaling challenges, which I have separated across general scaling challenges, instance and number and distribution, and shared versus centralized service scaling. So scaling challenges, this is not magic, it's architecture. But you're going to have to deal with the control plane scaling. So the scaling of the cross-plane instance, your providers, your provider config, that has to be performant. When you're, let's say, adding a lot of extra tools to your platform as well, like your Argo CD, like your Keycloak, they are still part of the control plane. And you might, let's say, have management overhead when dealing with multiple tool instances with multiple versions. So you kind of want to try to standardize and be a little bit strict with the amount of versions that you're supporting for a platform, which would then, of course, push your tenants to have to keep themselves updated a bit more. Also, because you're managing everything from one cluster, the state management across clusters does depend on the network and on the correct permissions. I need to be able to talk from one cluster, I need to be able to talk to the other cluster. So if network connectivity goes down, if my permissions are wrong, I'm not going to be able to continuously reconcile the state of that, of my resources, right? Whether that is the host cluster or the guest virtual clusters. You're also going to have to deal with that instance number and distribution, right? It's not only technical, but it's also strategic. You need to understand the solution's multi-tenancy construct and whether that is enough separation, whether that is enough isolation. You need to understand what is the usage of those components. Am I actually going to have noisy neighbors, or is this going to be utilized very little? Sometimes it's just easier to provide a new instance, right? But if we're talking about thousands of tenants, then obviously that's going to be a lot more. Let's say that you're going to need to run, so it's going to have an effect on your costs. So you have to be quite strategical about that number and instance distribution. And as well, maybe a single Argo CD doesn't cut it for a tenant. So they might also need a second instance, right? So how are they going to consume that? You're going to have to take care of that. And you must also, again, understand load characteristics of the applications. When is the performance going down? Because at that point, that's when you're going to need either more instances or, again, more replicas of the same instance. Now, on the shared versus centralized service scaling, this needs real architecture decisions. So is that tenant isolation on the native multi-tenant constructs enough? Or not? Is the performance going down or not? So this is going to highly depend on the scale of your operations. That is why you also need to do pilot deployments with load testing. So you do need to test all the limits of what is the tipping point in which the performance is going to start going down. And of course, you're also going to need to take into account high availability of all those components, performance, and recovery if there's any disaster. Relax, though. It all starts with a great API design. You have to design for flexibility, composability, and clear contracts and self-service like in a buffet, not like room service. Oh, now, let me see. So I don't have a clock here. Okay, let me make this bigger. I'm just going to show you a little bit on how are we defining our resources, how are we defining our floors, our rooms, etc. So we're doing this with crossplane, with composite resource definitions, or with crossplane compositions, which is very similar. It's the same concept as a Terraform module, right? It's just grabbing a bunch of resources and renaming, creating some kind of abstraction around it. So we will need to have our composite resource definition. It's very similar to the definition of a CRD. So you will also have in here your OpenAPI v3 schema. You should be adding description of everything, because at the end, when your tenants are consuming your CRDs, you do not want to have to either help them by the hand or give them any kind of external documentation. Everything should be within that Kubernetes API. So in here, you can see that we're adding as well, like what lobby should this floor be in, and as well the square meters, etc. You can also add what are some required attributes that you should be adding and what are some optional ones. So that is the composite resource definition. That's like the CRD definition. But what has to happen, right? You can create a CRD on Kubernetes, but if you don't have any controller reconciliating, then you just have something empty. So for that, we're using the crossplane compositions. And in my case, I am also using composition functions. So that's also something to mention. For simpler abstractions with crossplane, you can use let's say, the initial way of using crossplane, which is like a patching strategy. But the problem is that there's only so much logic that you can apply with this patching strategy. And on top of that, you might end up with very, very large YAML files, which only you are going to be able to troubleshoot. So in here, we're just referencing a function that we need to use. And if we look at the functions, right now, this is with KCL. You can use Python, you can use Go, and I think that's it. Although there might be support for other languages. Now, in here, what are we creating? So for my floor, I am just creating a Helm release. Sorry, not for my floor. For the room, I'm creating a Helm release, which is my virtual cluster. And in here, that's where I'm going to configure everything else, right? So this is just a Helm chart configuration. So if I need to export the kube config to a specific secret for any other automation to work. So in this case, I need to have a predictable secret, because if I'm going to deploy things into it, I'm going to need a crossplane provider config, which is going to be able to target this virtual cluster. If I need to sync the ingress to the host, if I need to sync any amount of node pools, here is where you're going to be configuring it. Now, very quickly, down to the key takeaways. So your platform is not a hotel. This is a fact. But there are certain abstractions and certain constructs which might make sense in your context, in your organization, and be relatable to your tenants. So they're not going to consume rooms or floors, right? But they might consume a web application which has another bunch of resources. They don't have to care so much about what goes in the background. They just understand what a web application is. So in here, one of the key takeaways is about building the abstractions which make sense within your context. Now, you must also understand the trade-offs of implementing soft versus hard boundaries, as well as the risks associated with the breach of those boundaries. And last but not least, you must test your platform components and limits of scaling and at the appropriate boundaries before finding out during operation. So starting with the wrong decisions are going to make you firefight. That was it. Thank you all very much.
Thank you. It was very informative and very interesting. Do you have any questions? We have time for one quick question. Okay.
I have a question if you actually use Crossplane production and if you use this in Microsoft or...
I'm a solution architect. I don't have production right now, right? So I might help customers with implementing this. I know about very large customers, very large Microsoft customers, which are using Crossplane, having very impressive platforms. And hopefully you will be able to hear about it in KubeCon because I am submitting a talk with one of them. Thank you.
Thank you.
Okay, one more question and a break.
How many resources are managed by Crossplane? Just the number. Maybe.
What do you mean, a number of
Resources, I mean, just resources defined by CDRs of Crossplane.
Yeah. Well, that's going to be as many as you want, right? So you're going to have
But in your, I mean, the real deployment.
On the real deployment. No, this infinite hotel, this is all kind of like an explanation.
I know, but Crossplane does is like, it's just 1,000, 10,000, 100,000 of resources can handle Crossplane.
Well, you can definitely do thousands. I wouldn't know if you can have hundreds of thousands. I haven't encountered that scale either. But if you have that scenario, I would love to see it.
Okay, thank you so much. If you have more questions, please approach Carlos during breaks. And now 10-minute break, and let's go out and network and be back in 10 minutes for next sessions.
Thank you.